Hello, welcome back. In this lecture, we shall discuss what is a bit plane slicing, how an image can be decomposed into its various components. Here, see that this is the original image. This is a grayscale, therefore, each values are represented in terms of 8 bits. If all the 8 bits are decomposed into separate layer, then this will be the 0th bit. This is the this one is the 0th bit if the image is plotted 0, and this is the data available from the first bit plane, and this much if we show only the second bit plane, third, fourth, 5, 6, 7th, and now. Now as you can see from the figure, the 7th plane data constitutes the major components, the major data of the actual figure. Right, now this I will show with a simple example. See that I have taken some data 25, 95, 123, and if I write in binary, this is how the data is split into 8 bits. And now this one, the rightmost bits is called as the least significant bit. Why it is called as least significant bit? Because where the weight is very less. This weight is 1, the next bit weight is 2, this weight is equal to 2, and this weight it has even more value 4, and this has even more value 8, and its weight is equal to 16, this weight is equal to 32, and this weight is equal to 64, and this has the major weight is equal to 128. Therefore, if data is lost here in this bit, then almost we are adding or losing 128 value. If the data is lost here, then it is only a loss or gain of 64. If there is a change in this bit, then it is a plus or minus 32. And likewise, if there is a plus or minus in this bit, it is a gain of 1 or it is a loss of 1. Therefore, this plane, that is the least significant bit, as the name suggests, it is least significant. Whether the bits are there or no, it is not going to affect the quality of the image. Compared to this one is the next higher level, and the most significant is this one. This data is very crucial, this data is very important. If this data bits are lost, then the most significant visual part is lost. You can see the figure. This is the 7th bit, this is the most significant bit. Therefore, see that the most of the constituents of the data is only in the 7th bit plane. Then next importance is 6th plane, next important is the 5th plane, and the least important is the 0th plane. Now our problem is, now what shall we do is, out of these 8 bits, let us extract the least significant bit alone, these bits alone. Then we shall show the figure. Then we shall take this one and we shall show the figure. We shall take this one and we shall show the figure. The concept, the logic is very simple. Now see this, I have taken the values 25, 95, 123 in MATLAB, right? Now I want the least significant bit. I want this one. Let me resize the window so that you can see this. I want only 1101. That is, I want the least bits. Therefore, what I can do is, I can divide each value of a by 2 so that I can get the remainder. See that I am getting 1101. Therefore, I get 1, and this one I will show that also simultaneously. See that 1101, I got it. Then how can I get the next bit, that is the second bit from the right? I want a 0101. I want this one, this bit I want. Then what can I do further? I can do this one. Again I can apply this I have to divide, and I can take the left value. Therefore, what I can do is, mod of a, I divide by 2, and then I take this value. Then I get an error. I am sorry, this one mod of a, I divide by 2, then I take 2 means I see that I am getting 0.5, I have 1.5. These decimal places I don't want, I want those values to be in nearest integer, therefore I take the lower value, therefore floor of a by 2. Now you can see that I am getting the next value 0, 1, 0, 1, 0, 1, 0, 1. Likewise, suppose if I want the next value, then what I can do? The same concept I can apply. Now here I can apply floor of a divided by 4. Then I will get this one, the third bit from the right hand side, 0. Yes, I got the third bit. When I divide by 4, I got 0, 1, 0, 1. So this is the third bit, 0, 1, 0, 1. And likewise, again if I divide, I can extract this bit, 1, 1, 1, 0. How can I do that? I can divide by 8. So simple. I am getting 1, 1, 1, 0. See that I am getting 1, 1, 1, 0. That is the fourth bit from the right. How can I get this one? 1, 1, 1, 0. Again I can apply the same logic. Now this I divide by 16 and I take the remainder. Therefore I am getting 1, 1, 1, 0. So good. Now let us take this one, 0, 0, 1, 0. I want 1, 2, 3, 4, 5, 6 bit. Therefore again I can apply, instead of dividing by 16, I divide by 32 and I see that I am getting 0, 0, 0, 0, 1, 0. Yes, here see that I am getting 0, 0, 1, 0. How can I get the last but one most significant bit? I can divide this by 64. I can divide by the weight 64 and see that I am getting 0, 1, 1, 0. That is the bit which corresponds to the 64 bits, 0, 1, 1, 0. Yes, I got 0, 1, 1, 0 which corresponds to the weight 64. How can I extract the most significant bit? I have to divide by 128. You see here, let us divide by 128 and let us take the remainder. Yes, I am getting 0, 0, 0, 0. Right, that is what my most significant bit is. My most significant bit is very important and my least significant bit is not at all important. Right, now we shall chop these 8 bits into we shall call this one is B0, B1, B2, B3, B4, B5, B6, B7 and let us plot these things independently. Right, which is once you know the logic, now let us do this one. I take this, I clear all these things and now let us start for fresh. Let us close all the figures if it is open. Let us clear all the memory location, clear the command window. Now I will take an image. Suppose this one is equal to IM and I take IM read. Let us take the same figure camera man dot take. Alright. Now let us show this one IM show and which one IM and let us call this one as equal to, give a title. This is the original image. Let us see up to this whether we can able to access this. Yes, this is my original image cameraman.tiff. Now I want the least significant bit. How can I do that? I can take the remainder of IM by 2. Alright, therefore now if I get an IM should have been this one IM comma 2. Now I can show this one IM show only B0. Alright, and then I can give the title is equal to this one is what? The least significant bit, that is bit 0 image is this one. Alright, now let us see whether I can get it. Now see that bit 0 it has nothing and basically what it see that it is only zeros and ones. Right, I did not put a semicolon, therefore it is going this one. Alright, now the same way, now let us take the next part. I can take B1 is equal to, as I said in that logic, let us take the lower value of IM by 2, let us divide by 2 and then take the remainder and now let us show this one is equal to B1 and this is my bit 1 plane. Now let us say run this. Here also I get it because all my values are only unsigned integer, therefore I am getting only the logical values 0, 1, 0, 1 and all. Therefore what shall we do is we shall make this image is equal to double. Therefore IM is equal to this one is equal to double of IM and now let us try this one. Yes, now see that this one is equal to bit 1, right? Bit 1 I got it. Now once I know that I can, yes, this is required because we want here itself in B0, therefore let us paste it here. And once if I know the bit 0 and I'm showing the bit 0. Likewise bit 1 and I'm showing the bit 1. Right, the same concept we can apply. So here this I copy this one and I paste it. This is B2, B3, 4, 5, 6, 7. Right, this I will take it as bit 2, 3 and 4, and meanwhile I will 128, and therefore here I am showing the image B2, here I show the image B3, and this image I show B4, B5, B6, and this is the most significant bit B7. So here I call this as bit 0, bit 1, this is bit 2, and this is bit 3 from the left hand side, bit 4 from the left hand side, bit 5, and this is the bit 6, and this one is of course bit 7. Bit 7 is your most significant bit, and whereas your bit 0 is your least significant bit, where the values are very least significant. If at all it is lost, it is a plus or minus 1 value only. Alright, now all these things we want, therefore I should have shown IM show, therefore I should have done like this figure comma, so that all the figures are retimed. Therefore, alright, let us do this 1, 2, 3, 4, 5, and 6, and 7, and 8. Right, 8 figures I have. Let us save all these things and let us run this. And here now you can see that almost all my bits are there. This is the most, let us take this one. Let us take the actual figure. The actual figure should have been figure 1. So this is my actual figure. And this one is my 7th bit, the most significant bit, and likewise my 6th bit. This one, how do we calculate the 1, and this one is my 7th, 0th bit, which has very less data. Alright, now let us see this one, how does the this bit 1 appears. So this is my bit 1. See that very partial data of the cameraman, because this is also the least significant bit, where the weight is equal to 1D2. Alright, then here the next image is equal to this one. This is bit 2. Bit 2 has a weight of 4. Therefore here see that even the cameraman is looking little bit more clearly in the sense more used data is there. Alright, then let us see this image. This one is equal to bit 3. Bit 3 has a weight of 1, 2, 4. Alright, this already we discussed, and this weight is equal to 4. 1, 2, 4, 8. This has the weight of 8. See that the stand, the building, and other things are coming. The picture is becoming a little bit more data is coming, and this is bit 5. Even more data is there, and likewise this one is bit 8. Bit 8 is, see that this one has even more this one has even more important data. Alright, so only these are the only 2-bit planes which have the very important information of data, and all other bits are very less important data. That is why this one is most significant bit, bit 7, and this one is bit 6. All other are very least significant bit. So here we discussed a simple logic how the bits could be extracted. Here this one, if 8 bits are there, how this can be extracted and plotted, and how this can be extracted and plotted, and how the image looks like when only the most significant bit of data is plotted, and how the least significant bit data alone appears. So a simple analogy, simple algorithm to extract the bit of data by a simple example of mod of by 2 and taking the lower value and dividing by 2. Hope this would have given a simple understanding. Please do comment my videos. Please do subscribe. Your comments alone are a source of encouragement for me. Thank you so much. I once again thank you and expecting your comments very eagerly. Thank you.